Hi everyone, I'm Dr. G. Swapna, Assistant Professor in the Department of Mathematics, VNR VJIT. Today we are going to start with partial differential equations. First, we start with how the partial differential equation is formed. For the formation of partial differential equations, we have two ways are there. That is, one is elimination of arbitrary constants and another one is elimination of arbitrary functions. Now start with the elimination of arbitrary constants. We consider an equation f of x, y, z, a comma b is equals to 0. In this equation, if we observe, z is the dependent variable. Both x and y are the independent variables. A and b are the arbitrary constants. Here the relation which gives in this having only one dependent variable and it is having more than one independent variables are there. So the equation which we obtained from this relation is a partial differential equation because it's having more than one independent variable. The given relation having a more than one independent variable, then we obtain partial differential equation. So here the number of arbitrary constants are a comma b. We need to eliminate those. How to eliminate? Just by differentiating the given equation with respect to x and y, and you will get the two equations. So from those two equations and together with the given equation, eliminate a and b and find out the expression in terms of x, y, z and p and q is equals to 0, which is the differential equation of first order. And here PE has the standard notation dou z by dou x, q is dou z by dou y. These are the standard notations in partial differential equations. Now here we observe here the differential equation which is having two independent variables and two arbitrary constants. From this equation we obtain the differential equation, partial differential equation of first order, that we need to remember here. The differential equation having a two arbitrary constants is formed the partial differential equation of first order. Now we look into an example. So here we take an example, z is equals to x square by a square plus y square by b square. In this equation, z is the dependent, x and y are the independent variables, and a and b are the arbitrary constants. In this equation, we need to eliminate a and b. So to that, we differentiate the equation with respect to x first, one of the independent variable. Differentiate given equation with respect to x partially. It means that keep y as a constant. Keep y as a constant. So dou z by dou x, this we are denoted it as a p, which is 1 by a square is a constant, derivative of x square is 2x, plus here 1 by b square is a constant anyway, y is also another independent variable which we are treating as a constant. It means that entire the term y square by b square is constant. So derivative of constant is 0. From this we can find out 1 by a square as p by 2x. Next, again differentiate with respect to y partially. It means that take x as a constant. So dou z by dou y, it is denoted as a q. Dou z by dou y is equals to, here x square is a constant because we are differentiating with respect to y. We treat x as a constant, that is the basic concept of partial derivatives. So x is a constant, a is also a constant. So entire the term is a constant. So derivative of constant is 0 plus 1 by b square into derivative of y square is 2y. From this, again obtain 1 by b square as, just simplify, you will get it as q by 2y. Substitute these 1 by a square and 1 by b square in the given equation. Substitute 1 by a square and 1 by b square in the given equation. Then you will get it as z is equals to x square into 1 by a square. 1 by a square is replaced with p by 2x plus y square into 1 by b square is replaced with q by 2y. Just simplifying, you will get it as px plus qy is equals to 2z. Here if we observe, this differential equation is of order 1. So what we discussed in the last slide, so here when the equation, the given relation is having a 2 arbitrary constant, then we obtain the partial differential equation of order 1. Just here we observe. Now take one more example here. Obtain the partial differential equation from the equation z is equals to ax plus by plus a square plus b square. Here also observe the number of independent variables are 2, arbitrary constants are also 2. So that means what is the partial differential equation which we obtain in which order? The obtained partial differential equation is of order 1 because whenever the equation, the relation is having a 2 arbitrary constant, then we obtain the partial differential equation of order 1. Now look into that, whether it is 1 or not. Differentiate partially with respect to x. It means that take y constant. So differentiate the given equation, dou z by dou x. So it is represented as a p. A is a constant, it is an arbitrary constant. A into derivative of x is 1 plus here by, b is a constant and y is also treated as a constant. So derivative of constant is 0. Here a square plus b square is also a constant, then it is 0. Then you will get it as a is equals to p. Now again differentiate partially with respect to y by keeping x constant. So dou z by dou y. Here we differentiate every time the given differential equation, not the others. Differentiate the given equation with respect to x here and differentiate the given equation with respect to y. Now that's represented as a q. Q is equals to dou z by dou y is ax is a constant 0 plus b into derivative of y with respect to y is 1 plus 0. Then b is equals to q. Just substitute these a and b values in the given equation. Then we will obtain the partial differential equation. So the required partial differential equation is px plus qy plus p square plus q square. Here this is our required partial differential equation. Here the order of differential equation is p or q means that, what do you mean by p? Dou z by dou x. Q means that dou z by dou y. Here that first order derivative. So the order of this differential equation is 1. So whenever the given relation is having a two arbitrary constants, then we obtain the partial differential equation of order 1. Now, we will learn about that next method, elimination of arbitrary function. How the partial differential equation is obtained by eliminating arbitrary functions. What is the order of differential equation which we obtain? The order of partial differential equation obtained by eliminating arbitrary function is same as the number of arbitrary functions given in the equation. Now, I will explain with the example. Form the partial differential equation by eliminating from z is equals to f of x square minus y square. If we take z is equals to f of x square minus y square. Here we eliminate f. We eliminate f by differentiating the given equation with respect to independent variables. Here the independent variables are x and y. So differentiate the given differential equation with respect to x and y, one after the other partially. So differentiate z with respect to x partially by taking y constant. So dou z by dou x is, so as you know, this dou z by dou x is denoted with p, which is derivative of f, whether it is an ordinary or partial. The derivative of sine is always cos. The derivative of cos is always minus sine. The derivative of tan is secant square. There is no change in that function. So we can represent it as derivative of f is f dash of x square minus y square into derivative of the inner function. This function with respect to x. So derivative of x square is 2x minus derivative of y square is 0 because y is a constant. So it is 2x into f dash of x square minus y square. Now again differentiate z with respect to y partially by taking x a constant. So that dou z by dou y, that is represented as a q, which is again derivative of f with respect to y, there is no change, f dash of x square minus y square into derivative of the inner function. Derivative of x square is 0, derivative of y square is 2y. Now simplify this. Minus 2y into f dash of x square minus y square. Let it be considered this one as equation 1, this one as equation 2. Now, how to eliminate from this? Here, if you want, you can use the given equation. From equation 1, 2 and the given equation, we need to eliminate f or derivative of f. Observe the equation 1 and 2. If we divide the 1 and 2, this f dash is cancelled. Then obviously that's elimination of f is over. Now, here observe, p is equals to, from the previous slide, p is equals to 2x into f dash of x square minus y square, and q is equals to minus 2y into f dash of x square minus y square. Just divide with one another. Just find it out. P by q is equals to 2x by f dash of x square minus y square by minus 2y into f dash of x square minus y square. So these two gets cancelled. You will get it as p by q is equals to minus x by y. So which is nothing but py plus qx is equals to 0. Here if we observe, what is the order of this differential equation? 1. How many arbitrary functions are given in the equation? That is only 1. So whenever the equation having one arbitrary function, then you will get or you will obtain the partial differential equation of order 1 only. Now we'll look into another example. Form the partial differential equation by eliminating from the relation z is equals to f of x plus at plus capital F of x minus at. How many arbitrary functions are here? Two arbitrary functions. So we can guess that the partial differential equation which we obtain from this relation is of order 2. Now let us take here. What are the independent variables? 2, that is x and y. It means that we need to differentiate the dependent variable with respect to x and also y. Now differentiate, let it be considered this as equation 1, the given equation as 1. Differentiate equation 1 with respect to x. Sorry guys, here the independent variable is not y, that is t. X and t are the independent variables. So differentiate the given equation with respect to x and take it as t constant because we are applying the partial derivative. So dou z by dou x, derivative of f is f dash of x plus at into derivative of the inner function is 1 plus f dash of x derivative of capital F is again f dash of x minus at into derivative of inner function is 1. Now because it is having a second order derivative, so you can apply the second order derivative, you can find the second order derivative also. Dou square z by dou x square, differentiate the above equation with respect to x again by taking t as a constant. So again the derivative of f dash is f double dash. F double dash of x minus at into derivative of the inner function is 1. Sorry, f double dash. So again differentiating the f dash, that becomes f double dash of x minus at into derivative of inner function is 1. Next, again differentiate equation 1 with respect to y, sorry, with respect to t partially by taking x constant. So dou z by dou t is derivative of f with respect to is f dash of x plus at into derivative of the inner function with respect to t. It means that x is a constant, so derivative of constant is 0, a into derivative of t is 1 plus derivative of another function is again f dash of x minus at into derivative of the inner function with respect to t. That is x is a constant, 0 minus a into 1. Derivative of t is 1. Just simplify this. Dou z by dou t is a into f dash of x plus at plus capital F dash of x minus at into minus a. Now again differentiate this equation with respect to t again. Second derivative, dou square z by dou t square. Why we are applying the second derivative here? Because it is having two arbitrary functions. So maximum the differential equation of order 2. That's why we are finding that second order derivative. A into derivative of f dash is f double dash of x plus at into derivative of the inner function x plus at is again a, because we are differentiating with respect to t, x is a constant, 0 plus a into 1 plus derivative of f dash is again f double dash of x minus at into derivative of the inner function. Derivative of x is 0. Derivative of this term is minus a into 1 because with respect to t. Now, if we observe these equations, Is these are enough, or we need to find another second order derivative? We have one more term is there in the second order, that is dou square z by dou x dou t. Dou square z by dou x dou t. If it necessary, then you can find it out. Otherwise, no need to find it. Here, if we observe 2 and 3 equations, if we take it as a, say, if we take it as a square as a common from the third equation, then we can relate with equation 2. We can eliminate small f double dash and capital F double dash. From equations 2 and 3, from 2 and 3, dou square z by dou t square is equals to, take a square as a common from the last equation, from the equation 3. Here take a into a is a square, and if we write one more term, a square into f double dash of x minus at. Here minus a whole square, that's again plus a square into f double dash of x minus at. Take a square as a common and relate with the equation 2. Dou square z by, so it's not dou square, a square into f double dash of x plus at plus capital F double dash of x minus at. If we observe, this is same as equation 2. So here from observed equation 2, this is nothing but dou square z by dou x square. That we can replace from equation 2. Dou square z by dou t square is same as a square into dou square z by dou x square. Because here we observe this f double dash, small f double dash plus capital F double dash is nothing but dou square z by dou x square. That we are replacing in this step. Dou square z by dou t square is equals to a square into dou square z by dou x square. This is our required the partial differential equation of order 2. Or how many functions or arbitrary functions given in the equation? 2, small f and capital F. So we will obtain the partial differential equation of order 2. Here a is no, we didn't consider here a is a constant. We consider we are eliminating either arbitrary constants or arbitrary functions, not the mixing of two. Okay guys, thank you all. We will continue the next topic in the next video sessions. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.